Okay, so this one you might need to really pay attention. So derivative rules, the product rule. That is when you have two separate functions being multiplied. So for example, if you have f of x is equal to 3x squared y cubed, well, this is a term, and this is a term, and those two things are being multiplied. Or you could pull the constant 3 out, and then you would have x squared times y cubed. So when there are two functions being multiplied within one function, this is the product rule. It says, so this is the first function, this is f, this is g. Take the original f function, multiply it by the derivative of the second function, then add this product. Here's a product you're going to add. Then you take the original g and you multiply it by the derivative of f. So here's an example of that. And by the way, I recommend when you do this, always have this formula written down, and then the tip I'll show you in a second. So here we have f of x is equal to 3x squared on the outside of parentheses, and on the inside x to the fifth subtract 5. This is just one function. This is just this function right here. But look it's a product of two separate functions. So here's my big tip. It's very helpful. Rewrite what the f function is, 3x squared. Rewrite the g function, x to the fifth subtract 5. Then take a moment and write what the derivative of this is, 6x to the first, and then write the derivative of what the g function is. So the derivative of a constant is 0, so that's going to cancel, and the derivative of x to the fifth is 5x to the fourth. Because once you have that identified, then you can take each of these. So this function would get put there, this function there. Then, let me change colors. Then this function goes there, this function goes there, and then it's just you doing some basic multiplication. So here's the function. Let's apply the rule. So the first part says f of x. So we're going to take 3x squared, and we're going to multiply it by the derivative of g. Well, here's the derivative of g, 5x to the fourth. Okay, then we're going to add the original g, this expression, x to the fifth subtract 5. Multiply that by the derivative of f, which is 6x. And now you can just use your algebra skills. Multiply these two things together, 3 times 5, and then x squared times x to the fourth, and then multiply those by doing the distributive. So now what we have is 3x squared times 5x to the fourth is 15x to the sixth, and 6x times x to the fifth is 6x to the sixth. 6x times negative 5 is negative 30x. And hopefully what you can see is those two things can be added together. And there you have the derivative. And at a given x value, so this is the derivative. This is the function that when you put in an x value, it will give you the slope. But let me show you a little tip with this. Let me show you a tip. For that one right there, because there were no y's, they were both just x's, we could have done this faster. You could just do the distributive first. And then that becomes 3x to the seventh subtract 15x squared. Is that what I have right there? And then look at it, you could take the derivative of each piece. So this 7 comes down in front, leaving 21x, and then 7 subtract 1, 21x to the sixth. This 2 comes around in front, 30x, 2 subtract 1 is 1, so we don't have to put it. So 21x to the sixth subtract 30x. And that's what our answer was here. So you can't do that with all of them very easily, but look at what you have here. That first example I gave you, when we had f of x is equal, say, 3x squared y cubed. Well, that's just a product. You can't simplify that further. But when you can simplify it, sometimes that's an easier route. All right, that's it for the product rule.